everybody, this is our Limits and Derivatives unit. We're on video 6 and we're working with the average rate of change. Alright, so let's remind you that rate of change is really looking at the slope or the time, the change over a period of time. And so for this particular example, we're going to be taking the total change divided by the time taken for that change to occur. So our first example from your note sheet talks about the population change in Schaumburg. So the average rate of change is going to be basically taking our 2 points, it's our slope formula, over a time period from A to B. So in this case, our time, we'll just pick 2 of these points and we'll calculate the slope for that. So for the first one, we're looking at the population in the growth or the average rate of change between 1850 to 1880. So typically we like to start with the farther date just because we think of it as being a positive change. So from 1880, I would look at 10,400 minus the population in 1850, which is 3,200. Remember, I'm putting my population, so people per year, and if you think of it like that, it's not years per people, it's people per year. So whatever you say first naturally is what is in your numerator. So people per year, and then my years are 1880 minus 1850. So a quick calculation will tell us the average rate of change between 1850 and 1880. When we calculate this, we get 240 people per year. Okay, so let's do that again for 1880 to 1900. So I'll look at the amount of people, the population in 1900 to be 27,800. Subtract the number of people in 1880, which is 10,400. And we'll divide that by the time that's passed, which is going to be 1900 minus 1880, or 20 years. Well, again, once you calculate that, we will find the average rate of change, or population change, over that time period. And this gives us 870 people per year. All right, let's try the next example. All right, for example number 2, we're going to be looking at a barrel of maple syrup that is being tapped. So we're basically draining this barrel of maple syrup. Time is going to be greater than or equal to 0, makes sense, and the total amount of maple syrup that is poured out at that time. Okay, so now what we're looking for here is the gallons per minute that have occurred. So to compute the average rate of change, the gallons per minute, over 2 different time periods. So we're going to be looking from time 0 to time 4 and from time 4 to time 12, and those are minutes that have occurred. So as soon as we tap this, we have 54 minus 0 over 4 minus 0. So that is, we're using 4 and 0 as our times, and this gives us 13.5 gallons per minute. Okay, so as soon as we have drilled the hole or opened the plug and we're draining the syrup out of the barrel, it's coming out pretty fast, 13.5 gallons per minute. That's pretty fast. Well, let's look what happens as this barrel starts to drain, and we're talking about from time 4 to time 12, so minute 12. So that would be 100 minus 54 over 12 minus 4. Okay, remember our time is in the bottom because we're talking about gallons per minute, so minutes go in the denominator. And this is going to give us approximately 5.75 gallons per minute. And let's just kind of investigate that for just a second here. As soon as you open the barrel up and you start draining it from the bottom, it is just pouring out at 13.5 gallons per minute. Well, then once it starts to decrease in volume, we're down to, at the last part of this here, at 12 minutes, or the average time or average rate here between 4 and 12 minutes, it's definitely decreased in its amount of, or its rate of emptying. So kind of something to think about there. It makes sense that it's a slower speed here towards the end. All right, I'm leaving example 3 for you to work on your own, so I'll be looking for that to be done when I check over your notes. If you want to stop now and go ahead and do that, that's fine. Otherwise, I'm going to continue with the back of the worksheet. All right, we're going to continue on that example of maple syrup, but this time I'm going to be looking for an instantaneous rate of change of a function. Now, instantaneous rate of change is that at a very specific time. I'm not looking over this broad amount of time to say, oh, I think the change is going to be anywhere between this and this. I'm looking at it in a very exact, precise time. I want to know what is the rate that is occurring right there. So to do this, we're going to kind of narrow in. It's kind of that idea of approaching time t. I'm going to be approaching time t, but I'm looking at what's happening on both. So I've put in some values here, and we are going to find the change as we approach from one direction and from the other. So we're going to be calculating two rates here. The first one is going to be from 2 to 4, and the second one's going to be from 4 to 6. So exactly what we did on the previous example here, but we're going to get narrow and more close in to what happens. So at 2, this first one is going to be 54.03 minus 35.83 over, well, 4 minus 2 minutes. We'll calculate that one. We'll also calculate from 6 to 4, so I'm using the other group, 68.11 minus 54.03 divided by 6 minus 4 minutes. Okay, so the same amount of time as I'm approaching, so I'm going to keep this symmetric. Alright, so after you calculate these two, you should see that this one is 9.1 gallons per minute and the other one is 7.04. Okay, so that's where we are approximately if you were to look at this graph. Alright, so let's narrow in a little bit more onto time t equals 4. So rather than have 2 seconds, or 2 minutes, I'm going to look at 3.8 minutes, and rather than 6, we're going to get really close to 4. We're going to go to 4.2 minutes. So really close to 4. Okay, so go ahead there and calculate the same way you did above at 54.03 minus 52.45 over 4 minus 3.8. We'll do that again with 55.57 minus 54.03 over 4.2 minus 4. Okay, so take a second and you can calculate those. Make sure you're trying these so you're not just copying and you know exactly what you're typing here. I get 7.9 gallons per minute, and for the other one I get 7.7. So it seems like our numbers are getting much closer, since in the previous part of this step in this process we had 9.1 on one side and 7.04. So it looks like we are approaching some sort of conclusion here. Alright, well, one more step. Let's get even closer than 3.8 and 4.2. So for this one, I'm using 3.98 minutes. So I'm practically at 4 minutes, and 4.02 is slightly over 4. So one more time we're going to calculate these, so give those a try. And I've drawn the conclusion here that we've got 7.75 and 7.85. And if those are the two values I come up with, and if I were to continue to follow this pattern, it seems to me that they would actually rest at exactly 4, as close as we can possibly get to 4. We would be at 7.8 gallons per minute when we hit 4. Exactly 4 minutes. And that's because I'm looking here at these two values. So my conclusion in words is, as the interval of time A to B, so my time frame, gets smaller and smaller, my average rate of change gets closer to my instantaneous rate of change. So on the first side of the worksheet, we just looked at a big broad span of how many minutes or how many years was something occurring over, and we said, well, what was the average for a bunch of years or for a long period of time? That was the average. Well, now I want to know what happens at exactly. What was the rate of change exactly at this spot? Exactly at time equals 4, or in exactly year equals 2000. Well, to do that, we just have to reduce the amount of time. It's using the idea of limits and approaching that. So in symbols, as the change, this delta means change, As the change in time gets smaller and smaller and approaches zero, my average rate of change approaches the instantaneous rate of change. So what I'd like you to walk away with from this video lesson is how to calculate the average rate of change, and that as close as you can move your average rates of change towards the actual time, you will approach an instantaneous rate of change. Make sure you try example number 3 from the front of the worksheet, and then we'll be able to answer any questions you have when I see you next. Good job!